Hi and welcome to this episode. I'm going to be showing you how to design your pile foundation. These are the things we are actually going to be considering in our pile. Okay, so you can see where you have your pile is less than or equal to 600 mm. For you to know your pile cap depth, it is 2 times the diameter of that pile plus 100. When the pile is greater than 600, the pile cap depth is 8 times the diameter of that pile minus 600 divided by 3. And then the penetration depth is 75 to 150 mm. Okay, so let's jump right into it. We already have our soil report, which is one very important aspect that you must have. You must have your soil report already, and then the soil engineer will actually specify. You can see the depth foundation recommendation. And then from the soil report you'll be able to know the soil bearing capacity as well, and he will recommend the foundation. Okay, so if you read through, okay, you will be able to know. You can see from here safe bearing capacity for this safe bearing capacity of 90 kilonewton per meter square. So this is the soil bearing capacity of that area of that land. Okay, so if that is correct, all we need to do is to come back here and see from the list we have 300 board cast in place pile, 450 board cast in place, 600. Okay, their depth is 8 meters, and then the safe working load based on the cross section of that pile. You can see for 300 250, for 450 510, for 600 875. Okay, so if that is correct, all I need to do now is to come back here to my ProtaStructure and check the column that has the most critical load and design all of them with it. Okay, so if you check from here now, except you can do it individually and design each piles individually if you want, but you can see the combination one here. This is 319, which is 320 approximately. The first thing I'm going to do now is to know or determine how many number of piles each of this column will be carrying, will be under these columns. Okay, so so if I have for my 300 mm, if that is, let's say I want to adopt the 300 board cast in place pile. So let's say this is the pile size I want to adopt. So 250. Now I will do my 250, I will do my 320 divided by 250. So if I have 320 now divided by 250, I will be having the value of 1.28. okay, so what this means is that I'm going to be having approximately one pile on each of under these columns. Each of these columns I'm going to be having approximately one pile. Okay, so if that is correct, all I need to do now is to come back to I can just select all my columns if I use my filter. But mind you, it's important that you always check and change the change the soil bearing capacity, because whatever you do now has a great effect on your soil. Okay, so if your soil bearing capacity is not if everything is done right and the soil bearing capacity is wrong, you will definitely be having a very wrong result. So what we got there from the soil report is 90 kilonewton per meter based on what the soil engineer has specified as the geotechnical engineer. So if I click on OK, now what I'm going to do now is to select all the piles. I will use my filter and select all the columns. If I did select all my columns, and then select everything back, and then I will right click and I will come to insert pile cap. So it's loading in the background. So it pops up for us here, as you can see what we have here, but we'll actually have to redesign it. Then it's important you come to your settings here and arrange all of these things and put them right. You can see here the soil allowable stress of soil 90 kilonewton per meter square, which is correct. And then the pile cap, if you remember our penetration, we said it ranges from 75 to 150, so I'm going to leave it at 150. Okay, and you know, after doing that calculation where we divided, we got 1.28. so every column will be having approximately one pile under it. Okay, so then one thing we need to do now again is to know the pile size is 300, which is what we are adopting, and then the depth of the pile is 8 meters, which is what we have there. And then the ultimate compression capacity is gotten from this calculation when you multiply your 250 multiplied by 1.4, which is this is the ultimate compression. If you multiply, this is where this value is gotten from, the 250 safe working load multiplied by the factor of safety of 1.4. if you multiply by that, you are going to be having a value of 350. Okay, so this is where we got the 350 from. So you check the pile cap depth, the minimum depth, and then the maximum depth. This depth is gotten from here where I was showing you. If you do your pile cap when it is less than 600 mm, the pile cap depth should be 2 times d plus 300. So that will now be 2 times the diameter of the pile, which is 300 times plus, okay, I take that again, let me clear it. That will be 2 times 300 plus 100. Okay, so that will be 700. Okay, so here now I will type in 700. So the minimum depth, you can specify it to any value you feel is more convenient for you, but the maximum depth you calculate that. Okay, so if that is correct, we have all of these informations, right? Let's come to our pile here. Let's see if there's another information we need to put in here. Minimum steel bar size, you can specify the minimum steel bar size, the maximum steel bar size. Okay, minimum steel and distribution bar size. Okay, can have all of that here. So if all of this is correct, default part footing form. Okay, so I'll leave it as rectangle. Okay, so let's see if there's so many other things. Okay, so all of these informations are here now. The next thing I will do is to select all of these piles. I will select all of them and I will design all. So after redesigning, you can see number of piles all here that has been specified is 11111 pile, and then the size of the pile 250, the depth 500, and then this is the size of that our pile cap. Okay, so this is basically what the software has been able to generate for us. Okay, so if I click on OK now, you will see all of those pile caps and the piles will be there beneath. So this is basically how to come about your pile foundation using the ProtaStructure. Okay, so on the next episode we will actually be going to our Prota detail to generate our detailings. Okay, so I'll see you in the next episode.